And let's continue. Many applications involve transformations of exponential functions. Some of the most common applications in real life of exponential functions and their transformations are population growth, exponential decay, and compound interest. So, example, let t be the time in days. Okay, so at t equals 0, there were initially 20 bacteria. Okay, so at t equals 0, at time t, how many bacteria? The number of bacteria, let's say for example, y. The number of bacteria is 20 starting, okay? Suppose that the bacteria doubles every 100 hours. So meaning after 100 hours, what happens? This will become double man, so 20 times 2. After another 100 hours, 200 na. 200 hours, double na po ni siya. So, si 20 times 2 times 2. Kaya mo double man siya. Or we can rewrite this as 20 raised to 2 squared. After 100 na po, so we have t as 300. So, mo double na po ni 2 times 2. This one will double, so times 2. So, nanay pattern, 2 raised to 3. Okay? T at 400 hours, we have y. The pattern is now 20 times 2 raised to 4. And so on after every 100 hours. So how can we give the exponential model? So based on this one. Okay? So in general, the exponential model for this one is y equals y sub o. When we talk about y sub o, kana mga nay sub o diha, this is always your initial value. Okay? Or pwede a sub o, b sub o, and so on. Masya initial. So our y sub o here is this one. Your 20. Okay, so this is 20. Since mag-double man siya every time, so we have 2. Raised to, paano natin nakuha si 4, si 3, si 2, si 20? So we can have a relationship of your time t. Okay? 400 divided by what para magiging 4? That is 100. Okay, every 100 hours man. Okay? So this is now our exponential model. No? Starting with an observation, this one, then we can generalize. Okay? So, say for example, if this is triple, so the same thing, magiging 3 lang si 2. This will become 3. Quadruple, and so on. Okay? So, we have these results. Suppose a quantity y doubles. So, doubles man. Every t units of time. So, that is, from the previous example, that is our 100. So, if y sub o is the initial amount, this is the 20, then the quantity y after t units of time is given by this. So, muna ni siya si y is equal to 20 times 2 raised to your time over t. This is your y sub o. Okay? Another example in relation to the previous example. So, a population starts with 1,000 individuals and triples. So, triple na every 80 years. Give an exponential model for the situation. So, let's use this one. Okay, so the form is y is equal to y sub o. Triple, so 3 raised to what? T over capital T. What is our initial? Starts with 1,000. So 1,000. 3 raised to T, no, anytime, time T divided by every 80 years. So this is our capital T. So 80. So this is now our exponential model. Okay. Now the next question is, what is the size of the population after 100 years? So At t equals 100, substitute lang. So y is equal to 1,000 times 3 raised to 100 over 80. So use your calculator. Using your calculator, this is equal to 3,948.22. Okay? So you use your calculator. Next, half-life. Let's go to the half-life. The half-life of a radioactive substance is the time it takes for half of the substance to decay. So half. No? So if this is your stick, half-life is when ni siya mag-decay. Then kung nila nabilin, ang half na pod when ni ma-decay, magkagamay hantod magkagamay. So half-life. Suppose that the half-life of a certain radioactive substance is 10 days. Okay, and there are 10 grams initially. Determine the amount of substance remaining after 30 days. So let's examine. So at time equals 0, our initial, what is our initial? Say for example, NO. Initial na to is 10 grams. So after 10 days, pilay mabilin? Half. So 5 grams. After 20 days, pilay mabilin? 2.5 grams. Half man. A half-life. After 30 days, again, this is 1.25 grams. And so on. So the question is, determine the amount of substance remaining after 30 days. So, based on observation, after 30 days, 1.25 grams na lang ang mabilin. Okay? Remaining 1.25 grams of substance. Now, in general, we have this equation of the half-life. Okay, so N of T is the quantity of the substance remaining. N sub O is the initial. 1/2, since every 1/2 magudta, no? Half-life man. Then at time T elapse, and half-life of the substance. No, when mawala, mag-decay ang half of the substance. So applying this from the previous example, take note that NO is 10 grams. Okay? And of course, ang T1/2 niya, every 10 days siya mag-decay. Okay. So by substitution, now we have this N sub O. The question there is after 30 days, right? So after 30 days, so N at 30 is equal to, our N sub O initial is 10 grams times 1/2 raised to, at time is 30, divided by 10 days. So pila ni siya? Times 10, 1.25. So the same answer, 1.25 grams. Okay, next. Okay, last example will be the compound interest. Okay, by the way, this compound interest will be discussed in the next chapters. Okay, so let's have this first. So example 5, Mrs. De La Cruz invested 1,000 pesos in a company that offers 6% interest rate compounded annually. How much will this investment be worth at the end of each year for the next 5 years? Okay, so meaning ani magod ang this is how the compound interest works. So this is the principal or your initial value, and this is your rate, no, per year, or okay, compounded annually man. Okay, so at time equals 0, your money is, or say for example, investment I is 100,000. Okay, 100,000. At time equals 1, so your interest will be, your investment will become 100,000 times 1 plus the rate. The rate is 0.06, so 0.06. Okay? So by the formula, we have a formula, my God. So this will become 106,000. Okay? So at time 2 years, okay, at time 2 years, your previous interest or investment will become your new money. No, so ma-add na po na siya. So we have 106,000. That will be your new principal. Again, you multiply that with 1 plus 0.06. Okay, so we have 112,360. Okay, at time 3, your investment will become 112,360. Multiply it again by 1 plus 0.06. So this will become 119, 101.6. At time 4, the investment will become 119, 101.6 times 1 plus 0.6. Approximately 126,247.70. And last, your investment will become 247.70. Multiply it again by 1 plus 0.06, 133. 133,822.56. So manually, this is how we do, or we get the investment after 5 years of Mrs. De La Cruz. Okay, but in general, no, we can rewrite this one as an exponential form. This one. Okay, this is the formula for the future value in compound interest. So always multiply by 1 plus RT. Now this is your 1 plus 0.6. So the point here is we can use exponential function in computing the future amount of your investment compounded annually or bi-monthly and so on. Depende. Compound interest ni siya. Okay? I repeat, we will discuss this further in the next chapters. Okay? Then prepare for a short quiz.